This is problem 64 from chapter 15. In problem 64, ball A has a mass of 3 kilograms and is moving with a velocity of 8 meters per second when it makes a direct collision with ball B, which has a mass of 2 kilograms and is moving with a velocity of 4 meters per second. If the coefficient of restitution is 0.7, determine the velocity of each ball just after the collision. Neglect the size of the balls. So here's what we have in this problem. We have 3 kilogram ball A moving to the right at 8 meters per second and 2 kilogram ball B moving to the left at 4 meters per second. And we want to find the velocities of the balls after the collision. The velocity of ball A after the collision and the velocity of ball B after the collision give us two unknowns, so we're going to need to use two equations. Our first equation is the conservation of momentum. During the collision, we have the force that A exerts on B and the force that B exerts on A. Those forces are equal in magnitude and opposite in direction. So the impulse that we have during the collision is equal to 0. So my conservation of momentum tells me that the initial momentum, which is mass times velocity for ball A, so that's 3 times 8, plus the mass times the velocity for ball B, but ball B is going to the left, so that's a negative 4 for the velocity, so that's minus 2 times 4, is equal to the mass of ball A times the velocity of ball A after the collision plus the mass of ball B times the velocity of ball B after the collision. 3 times 8 is 24 minus 8, that gives us 16, and then we have 3 times VA2 plus 2 times VB2. Our next equation comes from the coefficient of restitution. This is equation 1511. Coefficient of restitution is equal to the difference in the final velocities, VB2 minus VA2, over the difference in the initial velocities, but in this case, if we put B first here, we put A first in the denominator, so that's VA1 minus VB1. And it is important that we include the signs in this equation. So let's pretend I don't know the signs of the final velocity. So I'll just say VB2 minus VA2, and then I'll get something negative if it's going in the opposite direction. VA1, that's 8 in the positive direction. VB1 is 4 in the negative direction. I already have a negative sign there, so that's 8 plus 4. And my coefficient of restitution is 0.7. 8 plus 4 is 12, times 7 gives me 8.4, so VB2 minus VA2 is 8.4. And I will take this and solve it for VB2. So I have VB2 is equal to 8.4 plus VA2. So now I have an equation here. We'll call this equation 1, and an equation here. Let's call this equation 2. Now I can use equation 1 and equation 2 together. I can take this and put it in for VB2 here, and I get 16 is equal to 3 times VA2 plus 2 times VB2, but VB2 is 8.4 plus VA2. So now I have 16 is equal to 3 times VA2 plus 2 times 8.4 is 16.8 plus 2 times VA2. 3 times VA2 plus 2 times VA2 gives me 5 VA2, so I have 5 VA2 is equal to 16 minus 16.8 if I bring the 16.8 over to the other side. And then I can divide both sides by 5. And I get VA2 is equal to negative 0.8 divided by 5, which is minus 0.16 meters per second. This is the velocity for ball A after the collision. And for the velocity of ball B after the collision, we can go back and use equation 2. And we get VB2 is equal to 8.24 meters per second. So after the collision, ball A is moving to the left and ball B is moving to the right. And that concludes problem 64.